So, continuing back here on the mobility APIs track, we're going to shift from talking about integrated business process monitoring to API product management. This is where the API opportunities for solving new and different problems really come to life. And we're fortunate today to have Lasse Lumiaho from Vaisala with us here today. He's going to talk to us about weather forecast data and mobility. Welcome, Lasse. How are you today?
Thank you. Hey, good to be here.
Lovely to have you. Now, you've got 20 minutes to share your presentation, talk through, and I'll be taking any questions and for about 5 minutes at the end. The stage is yours. We can see you well.
All right. Hey, thank you.
Great.
Hi, so my name is Lasse Lumiaho. I work at Vaisala, a Finnish company that is focused on environmental measurements. Weather is something that impacts all of us, and environmental data in its different forms is becoming increasingly important and is one of the most important tools we have in our toolbox to fight global warming. One thing that you don't often get to say is that your company's products are operating on another planet. However, Vaisala provided sensors that are on board NASA's Perseverance rover, which landed on Mars in February 2021. I personally work with weather forecast data that we provide, for example, to car manufacturers and automotive technology providers. This is an extremely interesting area with some self-driving cars on roads already and fully autonomous vehicles just around the corner, to give a few examples. The latest and greatest achievements in weather forecasting, especially in road weather forecasting, might not be on your radar yet. Therefore, I'll be talking about how road condition forecasts are made and how vehicles can help drive in bad weather. If I would ask two people, is this road dry? I would most likely get two different answers. It isn't a trivial task to say if the road is dry or not, as you can see from this image. There are clearly areas that are dry and areas that are wet. If you're driving in the tracks, you could consider the road to be dry. Then again, when changing lanes, you would consider it to be wet. And for example, the wet surface would affect your car's braking distance. Providing actionable weather data that takes this type of complexity into account is something that we at Vaisala's forecasting team work on every day. The automotive industry is looking to improve safety on the roads, and weather plays a big role in road safety. We can't, of course, change the weather, but we can help the drivers and vehicles adjust their driving to the conditions, or perhaps choose a better start time. As you can see from the slide, road accident-related weather conditions appear globally, not just in the north where we have slippery winter conditions. Providing accurate weather information can truly make an impact, as about 1.3 million people die every year, and 20 to 50 million suffer non-fatal injuries in road crashes, according to the World Health Organization. Furthermore, according to WHO, road traffic crashes cost most countries 3% of their gross domestic product. So vehicles could definitely do more to make driving in bad conditions safer. The most cutting-edge technology for slippery roads in cars still today is the snow icon that is shown for temperatures below 4 degrees Celsius that you can see here in the picture. You would think that in this day and age, there would be something more accurate available, right? Now, let's take a bit deeper look at how road weather forecasts are generated and how drivers can be informed about bad driving conditions. A traditional weather forecast generation consists of 3 steps. First, gathering weather measurements globally, namely data from weather stations and satellites. This is actually a true global cooperation where all countries in the world participate. The global observations are gathered into a couple of locations where supercomputers process this data. And the processing output is a global weather forecast that extends multiple days into the future. Governmental organizations such as NOAA in North America and ECMWF in Europe do this sort of forecasting. Traditional weather forecasting is usually done a couple of times per day, and it takes a couple of hours to complete. This means that by the time we get the data, it's actually several hours old. And if we look at this from the perspective of providing accurate road conditions, we would prefer to have something that updates more frequently, say every few minutes. So to solve this frequency issue, a separate nowcasting process is usually applied by weather data providers. Nowcasting improves traditional weather forecasts by taking the latest observations, for example, satellite imagery, and uses machine learning and artificial intelligence to generate short-term forecasts. Running a nowcasting model takes only a couple of minutes, so we can afford to run it every time we get new radar or satellite data. For example, every 5 minutes. Nowcast-based forecasts usually extend about a couple of hours into the future, which is a pretty good match with the time range of many driving use cases. Most trips usually don't last longer than a couple of hours. Everything discussed here so far has been about weather in the atmosphere. To provide accurate road conditions, we still need to add one more layer, a road weather model. To predict road weather, you could use a machine learning model or a physics-based model. A road weather model simply predicts the road surface temperature and the amount of water, snow, and ice on the road surface. Now, to run a machine learning model, you would need road surface measurements from the location you want to predict for. And to cover a whole continent, you would need millions of road weather stations to use a machine learning model. It's not very practical to install and maintain that many stations. The alternative, a physics-based model, you can run anywhere where you have atmospheric forecast data available. Let's take a look at how a physics-based model works. In a physics-based model, road surface temperature is affected by solar radiation, radiative cooling, traffic, and de-icing activities. A road weather model also predicts the amount of water, snow, and ice on the roads to provide a road condition forecast. Water, snow, and ice is added by precipitation and removed by evaporation, maintenance activities, and traffic. The forecast model outputs the state of the road surface as multiple parameters. Let's look at a couple of graphs to give a better idea of what the output might be. A road weather model can forecast the road surface temperature, as shown here for continental US and southern parts of Canada. However, road temperature alone might not be the most interesting value to know when driving in bad weather. You probably want something more actionable, like a general road condition code. Now, take a look at all the locations that are blue, where temperature is below zero, for example, at the top. And keep this in mind. The driving conditions there should be bad. However, in the northern parts, you can see many areas are actually dry instead of snowy, slushy, or icy, even when the temperature is below. Let's quickly jump back to the previous slide so you can compare once more. So you can see at the top, it's really cold road surface, but the driving conditions are actually dry. So simply basing actions on road surface temperature alone would give a lot of false alarms to drivers. Forecast data is of course not the only source of weather data for vehicles. Nowadays, cars are more than just moving metal containers, and they host a variety of sensors, scanning the surroundings in addition to the ambient temperature sensor. Vehicle sensors can do a lot to improve the understanding of the immediate surroundings of the vehicle. They provide many different types of safety and comfort-related services for the driver, for example, adaptive cruise control, park assistance, and traffic sign recognition. Cameras can see visually the road and the condition of the road and any physical objects near the vehicle. Radars can scan the surroundings for nearby objects and the distance to the object. LiDARs, that is laser-based radars, can make sure that the car sees when the camera cannot see. LiDARs work in centimeter level detail, so it can really see in 3D almost at the same level of detail as a camera. It can, for example, see moving vehicles through a fog. Let's take an example. The Google-owned Waymo's vehicles operate in the streets of San Francisco, which is famous for its quickly changing weather conditions. For example, fog can appear without a warning. This image is from Waymo's blog post about how they tackle tricky weather conditions in San Francisco. On the left, you can see rain hitting the camera lens, altering the view. And on the right, you can see a LiDAR scan in foggy conditions. You can really see the surrounding vehicles in 3D, and you can even see some of the fog around the vehicle. So some pretty impressive technology there. To make use of the previously mentioned weather data, modern cars have plenty of capabilities available. They have an internet connectivity to query, for example, weather APIs for forecast data. They have computing power to process forecast and sensor data. And they have a modern operating system to display and inform human and machine drivers about weather conditions. Now, let's take a couple of examples of driving-related use cases where road condition information can make driving safer and more comfortable. Imagine you're planning a drive and the navigation app would show you what kind of weather you will experience on the way. If you knew that there will be heavy rain and snow coming, and delaying your start time by 15 minutes, you could avoid the heaviest snowfall, would that affect your start time or perhaps driving behavior? Electronic vehicles can also improve their range calculations if they would know, for example, wind temperature and air density on the route. As weather is tricky to forecast to the point, bad weather can come to your route when you've already started driving. Imagine getting this type of a heads-up message about upcoming slippery driving conditions on the road ahead, giving you a chance to prepare and adjust your driving style. Or if you have a highway pilot, your car might tell you to take over and grab the wheel. A third example, navigation applications can already today suggest a better route when a highway is blocked due to traffic. In the future, weather data could be one parameter that is taken into account when choosing the best route. Or it could be the deciding factor if your car can keep driving by itself or if you have to take control of the vehicle yourself. The automotive industry is a pretty exciting place to be at the moment, as connected vehicles are hitting the streets and fully autonomous vehicles are just around the corner. And weather-enabled services that will improve the safety and comfort of driving are also starting to appear in the market. And all these future services will be powered by APIs that deliver data to connected vehicles from various sources. I hope you've enjoyed my talk about road condition forecasting and how road conditions can help human and machine drivers in bad weather conditions. If you want to see some real-time weather forecasts with your own eyes and play around, just visit hello.wxhorizon.vaisala.com to create a free account. You can play around with our road weather data there. If you have any questions or comments, I would be more than happy to answer them at this point.
Thank you, Lasse. That was a fabulous presentation. I don't feel that I'm going to get in a car and the next time it's either been raining or going to rain and actually be going through the same thought process. So this connection between the big picture goals of safety and broader scale kind of health, but the responsibility for actually getting this data and using it sensibly seemed to me to come through very powerfully. I was wondering if you would be comfortable sharing some of the, as a product manager in product management role, some of the people that you're working with on a day-to-day basis to help and what sorts of organizations they're in to help explore and bring more of these not so futuristic concepts to life.
Yeah, so I mean, internally, there's of course the development team. So we have software developers and data scientists, then who also know the weather domain really well. So those are the kind of main daily contacts. And then of course the automotive industry is the customers are enterprise level. So often when you talk to customers, then you also work together with sales quite actively. Very different from consumer services, or if it would be kind of a SME or even like small B2B business. So those are the main, and then customer discussions still every week to dig into customers' needs and wants and to develop the offering.
And how much of that do you find how much of that time is actually kind of educating and exploring potential ideas as distinct from just feeding back into development teams of maybe known ideas?
Yeah, I'd say it's maybe 50-50. So I mean, what I just showed you is kind of still a new thing. So even the existing customers that we have might not know all the fancy new stuff that we have coming. So yeah, there is definitely the element of educating what's possible, and then the customers seeing how they could use it in their own services and what kind of products they could build with that data.
And are you how are you also kind of working within your other teams in such a large organization as yours? You've obviously got presumably a lot of hooks and connections, and maybe you're finding you're collaborating in different spaces maybe than traditionally in order to explore some of these opportunities?
Yeah, there's definitely different type of initiatives, and Vaisala is mainly a hardware company. So that is definitely a different kind of collaboration when the other teams, when they push something out, it's can be like 2-3 years before they get the new product out of the window, compared to software. You can just fix something today and then it's out in 15 minutes. So there is definitely a difference, and it just needs a lot of internal communication on to be in sync with what's happening and when would something need to happen.
No, absolutely fantastic to hear a bit of your story, and all of the very best of luck with exploring these new and positive horizons for us and for your organization. So thank you so much, Lasse, for joining us today and sharing your thoughts and observations and insights. Learned a lot.
Hey, thank you.
Thank you so much.